Hello and welcome to Maker Melissa's Lab. A few months ago I finished up my Prusa Bear, putting in the final touches, and this has actually been my main printer that I've been using for a lot of my jobs that require filament for a single color because it's actually been working so well. But I wanted to do a few last minute upgrades. One of the things when I set this up is because of the combination of these tall stepper motors here along with these couplers, I've noticed there are certain positions when this is all the way over, it will actually hit these couplers just a bit, and I've compensated by that by reducing the print area just a little bit. So mine gets about 5 millimeters less print area than you typically get on a Firmware Bear. Now Greg, the person who originally designed the Prusa Bear, and Jason from LDO Motors were kind enough to send me these integrated lead screw motors for the Z-axis. So in this episode I'm going to be replacing those. I'm also going to be installing a filament runout sensor, and I'll tell you more about that later. And I have this textured cable wrap that I got off of AliExpress, and I'm going to go ahead and replace what I have done here with two different ones. And so that'll end up looking a lot nicer. Let's get started. Now I wanted to start off by talking about this filament runout sensor here. I got it so I could put it in line here, and so it installs right on these PTFE tubes. This is actually a remix of somebody who had designed this for these roller sensors here. And I discovered when I was trying to test fit this that I had to actually slightly bend the roller sensor arm so that it would, with 100% accuracy, go and hit it every time. But this is actually working really well. I'll need to create a little wiring cable that'll go along here and connect to the board. For the lead motors, I have printed off these parts. They go a little shorter. These are the original design that comes with the Prusa Bear. The only modification I've done to these is I have modified them so they fit within my extrusion here. In fact, I've gone through all the parts that mate with any of this extrusion and modified it and reprinted it, and everything fits together very well right now. So the first thing I'm going to go ahead and do is open up this box here. Start by replacing this. Okay, I've kind of twisted this around here so that it's nice and smooth along here, and I'll just tuck it in right here. Let's get this box back on. Okay, I'm trying to do this here. I have the nut kind of propped up with a wrench or hex key or whatever you call it, and now I'm gonna, you almost need 3 hands to do this. Got it. No, no. Okay, I got a solution. Okay, I'm gonna put that like that. And then we're going to kind of put that over it. Got it. Okay. Let's do the same thing with this one. And then got it. Move that out of the way. Put that on. Put that on. Make sure it closes while that's in place. Tighten up that one. Tighten up that one. And we're good. Next, I'm going to start with the Z motors. I'm going to need to make sure that the connector is facing towards the inside of the printer. Start by taking these caps off the top here. Now let's take these off by just loosening them and then just sliding them up. Now let's get these all the way up. I forgot this whole thing can come off. So we'll go ahead and loosen these 4 screws here in the front. Then we'll slide these things out. Then we'll go ahead and do the ones in the back. If we just lift the straight rod out on each side, now the whole thing just slides out. Oh, I forgot. I have some clips holding these wires for the motors in. And I go ahead and carefully, not cut the wire, but remove the wire tie on each side. Looks like I had one of my labels come off here. Okay, now the whole thing's coming off, and then I can unscrew that, unscrew that, and for the moment I'm going to set these smooth rods into these holes just to kind of hold it in place. I need to cut some more of these wire ties so I can remove the motors. Here we go. Just came off by itself. Oops. Okay. These have been freed. Now the Z motors are going to look different, so I'm not going to worry about labeling them. Now I'm going to take these off. I already have a couple here from Prusa, which basically look the same as this. Okay, I'm going to have to take these smooth rods out here for the moment. We're going to set the whole X-axis down. The reason we want to do that is because we need to replace these first with these. Since I'm fighting gravity, I'm going to start with the top one. Now we'll loosen it a bit. I need to tighten these first. So I just have them all the way down. Make sure this is in. Let's go ahead and do the other side. Loosen that. Get that in place. Bring it up. And then get my tool out of there. Let's go ahead and make sure this is loose enough to bring all the way to the bottom. And tighten it all. Let's get our lead screw in here. Start off with the 2 rear screws here. I just realized a problem. I actually need to put this onto these lead screws before I push them in place, so let me go ahead and do that. Okay, let's make sure the motors are facing in. Slide that in place. Slide that in place. Put the smooth rod in here. Uh-oh, here's what we're going to do. I'm going to push that up. Let's make sure these are all tight. Okay, let's put in the rear screws again. Get the rear screws in on this side. Actually, before I tighten down too much, I should make sure these fit in. Just realized a problem. Because these are sitting lower now, my smooth rods need to be longer. So what I'm going to do for the time being is, until I can get some more smooth rods, I'm just going to do this and accept a little bit of Z height loss, so I'll have to readjust that in the firmware. Now the other option I could have done on here is, instead of having a little Z height loss for the moment, I could have used these still, and I wouldn't have had to worry about it hitting couplers because of the integrated lead screws here. But I'd rather have it going lower and just replace the smooth rods here. I'll have to figure out the correct length and order some of those. They should be very easy to replace. It should just be a matter of removing the caps here, loosening these, slipping them off, pulling the rod out, putting a new one in, and that's it. But it'll probably take a while to get here. And now the last thing I need to do is create a little wiring harness for this so that I can have that installed like that. Although it is a little bit weird. Let me make sure this isn't going to cause any problems with hitting this. Okay, yeah, we should be good. Of course there's wires coming off. You know what? I'm gonna just have it in like this and just have it bent off a little to the side. That way I can have the wires kind of going in, down the back of here and over into here. I happen to have this IR cable that was for the Prusa, and since this is supposed to have the filament sensor built into it at some point, I thought I'd go ahead and make use of this. Now in order to get this to connect to this, I was going to go ahead and use one of these little perf boards and cut it down to size and solder it on here, and then connect either this 90-degree angled header or this, depending on what looks like it'll work better, so that I can test the cable. But in the meantime, I'm going to use these little alligator clips here for making sure this filament sensor is going to work, since it was actually for an IR sensor. I'd imagine it will, but this will also help me with getting the wiring on here before I get the perf board connected. So what I'm going to go ahead and start by doing is plugging this in to the spot it needs to go into. And now let's go ahead and connect these. I imagine it is this and this, but I can always move it. Now I have a little piece of filament here. Okay, let's start by plugging this in. Okay. First, what we want to do is make sure the filament sensor is on. Then we want to go to support. And then go to sensor info. And what we want is the IR one. So 0 means there's no filament. That's not changing. Okay. Okay, we got a 1. So it looks like what we want is to attach the black and white wires when there's filament, and we want to attach it to the normally open one. Basically what it's doing is it's going to ground, which means I don't need the red at all, and it's just going to be attaching 2 wires. So let's go ahead and turn this off. Not perfect, but it'll work. What I want to do is attach it to all 3 of these contacts so that I have some strength, and then I'll solder a connector so that it goes between the common and the normally open. The common is the one with the C on here that's away from the roller, and then the normally open is the center one. Let's go ahead and solder it to this side since it looks like it's turned out a little bit better. Let's make sure I'm soldering it to the correct side here. I want it against that. Okay. Make sure it fits in here still. Looks good. I've decided to use the right angle one. It's going to be 2 on the same side. So I can always flip the cable around, so I'm not even going to bother looking. Very simple circuit here. Let's go ahead and test it out. Looks like that is working great. I measured out the screws and they were M2.5s. I didn't have long enough M2.5 screws, and so I took my drill and I drilled it out at 3mm using some metric drill bits, and now I am measuring these M3 screws. I just tried an M3 by 14 and it was too long, so now I'm about to try an M3 by 12 and see how that fits. That looks perfect. So let's go ahead and throw on a nut onto the end of here. And let's do a second screw. Okay. Make sure it still works. Easy ways to grab a little length of filament here. And it looks like it's working just fine. Next step is to get it wired into this cable wrap here. So that means I have to take off a bunch of wire ties. I'm going to create a little bit of a slack in here. And one of the reasons we want to do the slack is this could bend here as it's printing because maybe the filament catches, and this will make it so it's not going to break the connector. Just kind of going in here. Now let's feed this into the cable wrap. Now it's possible that once this has been modified to have an IR sensor in it, I may have to kind of change the slack a little bit, but this actually isn't as hard as I thought it would be. I need to go ahead and loosen this. Well, remove the little clip actually. If I remember right, this was really hard to get on here, but because it's been squeezed for so long, it may not be so hard this next time. Let's go and put this on here. There we go, that looks good. Let's hope this isn't too hard. I think I was turning this for a long time till it caught. Okay, that's not too bad. I think part of it was the fact that I remembered it was hard. Okay, this is looking really good. Just need to finish it off up here. Let's go ahead and secure some zip ties on here. Oops, upside down. Let's make sure it's plugged in the correct direction. Now before I secure the box, I need to attach the motor cables on. So we're going to go ahead and attach these on here. Now having the detachable cables here is really nice because they actually don't get in the way like they did when I was doing the other ones, and I had to kind of tie them up in a bundle. And I think even the ones on the Prusa are not detachable, so I'm really happy with these. Now this one's going to be a little bit long, but that's okay. I'm just going to plug it in and then just use a wire tie to kind of bundle it up so it comes in here a little neater. Turn that off. Let's make sure everything closes up. Let's go ahead and attach the screw in here. And so I need to make a couple more adjustments on here, and that includes the E-steps for the motor, because they're likely not the same as what I just had. Oh, this is an even level. And I need to adjust for the height on here. First thing we need to figure out is the number of steps for the distance. So a little trick you can do is kind of like hold this for a couple seconds and then automatically goes into the Z-axis. Yeah, I definitely need to, I think, increase that. So what we're going to start by doing is homing the axes. Axi? I'm not sure the right term is. Axes. Calibration. Auto home. Now, it's probably not perfectly level, but it's level enough. Well, I guess it's level now. Unless... Oh. Something's going on here. These two are not level. Why is this one lower? I have a suspicion that the smooth rod is in this hole more than it is in that hole. So let's go ahead and loosen everything up. Oh yeah, that was definitely not all the way down. There we go. It's just over 15 millimeters. .82. Yeah, this is definitely lower on this side. Ah, it wasn't quite on. Now let's make sure this is even. I think that's close enough. Let's try this again. Now what it's going to use is this penta probe to kind of check for the bed. Now one thing that we can do is we can put that in a specific spot, zeroed out, and then I'm going to go up 70 millimeters. And we went up an actual amount of 69.45. So that means we need the number of steps per millimeter to increase so that we're actually getting 70, is the way I think about it. So when I plug it into the firmware, I just do a little equation. Let me go ahead and pull this up here. So let's go ahead and connect to the printer. I have plugged it in. Okay, now we're connected to the printer. Printer is now online. Excellent. So let's go M503, and that'll tell us our current settings. Oh, here we go. Steps per unit. Our Z is currently 397.02, which is a little low. So we're going to go ahead and set M92 Z400. Make sure, okay, perfect, we're at Z400. Let's go ahead and home it now. Now let's go ahead and put it at the lowest setting by holding that down and then moving it so it says 0. Now we're going to go ahead and put this here. Okay, so we'll set it here so it's level. And we'll make sure it's on the flat part of the motor. Go up an even 70. And it is at 69.98, which actually is very, very good. And I'm going to go ahead and leave it there because I'm using calipers, so I'm going to account for a little bit of error. So next thing I need to do is go up to the highest level and see as high as it'll go before it will stop automatically. It should be about 297 or something like that. Maybe 296. Okay, let's go ahead and home this. Just want to be sure. I think 295 might be where I want it to be for its limit. Okay. Yeah, it looks like at 296 it's hitting it. So I'm going to go with 295 as the maximum height for now. All right, let's go into Arduino here. And I don't recall if I had it set for 311 or 312 for the maximum. Ah, looks like I had 312. So we're going to set that to 295. And let's verify. And it looks like it's good. Let's go ahead and make sure we're on Prusa Research INC Rambo. We're on COM9. Let's make sure we're not connected on here because it doesn't like it when you have two things connected at once. And let's go ahead and upload it. Now I don't recall if this resets the firmware on here for the EEPROM settings, but I have gone ahead and updated it in here as well. I think the EEPROM settings will retain their values. The reason for that is so you don't have to recalibrate your printer every single time you upgrade the firmware. And I believe we should be good at this point. So let's go ahead and test this out by going to calibration, and then we'll do auto home. Okay, let's go back to, oh, it automatically did. Go to the Z, and what we're going to try and do is go all the way to the top, and it should stop at 295 now. And perfect. So now when I get some more Z-rods, I will just go ahead and just bring it to its maximum, adjust the number in the firmware, and Should be that easy. And I hope you enjoyed that. Things didn't quite go as I was expecting with this being a little bit lower, but that's okay because I haven't really printed anything that gets it up to its limit here, and it's actually a pretty easy fix to get it so that I can get the full height again. The little filament switch turned out great. I was a little worried that the electrical connection wouldn't work because I didn't really try it out before the video, and so that's great to know that a mechanical switch will work in place of the infrared one. And we got the firmware updated. I did get to update the height in there, and I just updated the Z-axis steps through the Prusa software, and so that was actually really easy to use. And I went with the default 400 because I figured that's kind of how these had been designed, is to go with the default values, and it actually worked out really well, and so I'm happy with that. I haven't done any actual test prints, but I'm confident this thing's going to work just fine. I'm going to be doing plenty of prints after this. Now, to kind of summarize the things I've done, I've printed on this printer with PETG, with PLA, with ASA, and with TPU, and they all did well. The only one I had a little problem with was the TPU because I had set the bed temperature a little bit too high. I was printing it at 50 degrees instead of 40. Once I did that, it wasn't a problem, but the problem was it was stuck so well that when I went to go release it from here, it wouldn't come off, and I had to use a little spatula, and I kind of ruined the bed a little bit here because there's a little chip out of it. So I'm just going to use the other side here, and it's fine, and if I have to I can always get another Ulta stick. Lesson learned. The only other thing is this has just a little bit of looseness, and I might go ahead and tighten it up with some thread locker, but it really hasn't been an issue, so that's why I haven't done it yet. Other than that, I've been really happy with this printer. It prints great. I use this more than I use my Prusa printer, actually, because sometimes I don't like dealing with the MMU 2S on there because it can be a little finicky sometimes, and this gives me the option of doing it without that. The only things I was missing was the filament runout sensor, which I've taken care of now, and now I have my full build plate. I'll go ahead in my Prusa software and I'll update the print area to the full print size. And I just wanted to give a huge thank you to Greg and Jason from LDO Motors for sending these out to me. It made a huge difference on this printer, and I'm really happy with it. So thank you for watching this. I hope you enjoyed it, and be sure to subscribe if you aren't already, and if you are, thank you. And I'll see you in my next video.